Now let's see how to construct the circumcircle and incircle of a triangle. First, let's see how to construct the circumcircle of a triangle. Before we begin the construction, let us know what do you mean by circumcircle. Circumcircle of a triangle is a circle passing through all the vertices of a triangle. We know how to draw triangle, but for drawing circumcircle, we need to fix up the center and the radius. Let's look at the analysis of the construction. Look at the screen. These are three non-collinear points P, Q, and R. With the help of these three collinear points, we can construct a circle. Now let's see how. First, join points P and Q and draw the perpendicular bisector of segment PQ. Now join points Q and R and draw perpendicular bisector of segment QR. Now let the bisectors of segment PQ and segment QR intersect each other in one point O. The point O is equidistant from the 3 points P, Q, and R. Therefore, PO is equal to OQ is equal to OR. Now taking O as the center and OP as radius, if we draw the circle, then it passes through all the vertices of the triangle PQR. Now let's look at an example. Draw the circumcircle of triangle DEF, in which DE is equal to 5.2 centimeters, angle D is equal to 50 degrees, angle E is equal to 75 degrees. Now let's look at the construction. First draw segment DE of length 5.2 centimeters. Measure 50 degrees from point D and draw a ray. Now measure 75 degrees from point E and draw a ray. Now mark the point of intersection as F. Thus, we get the required triangle DEF. Taking more than half the distance, first keep point of compass on point D, then on E, and draw intersecting arcs above and below segment DE. Draw a line L passing through points of intersection of these arcs. This is the perpendicular bisector of side DE. Let the point of intersection of side DE be A. Similarly, draw perpendicular bisector of side EF, that is line M. Let the point of intersection of side EF be B. Mark the point of intersection of the lines L and M as O. Now take OB as radius and O as center. Draw a circle touching the vertices of the triangle DEF. Thus, this is the circumcircle of the triangle DEF. Now let's solve an activity related to circumcircle. Look at the screen. We have drawn 3 different types of triangles with its circumcircle. Let's write the inference about the location of circumcircle in the given table with the help of figures drawn. In the right angle triangle, the circumcenter is located on the hypotenuse, which is a midpoint. In the acute angle triangle, the circumcenter is located in the interior of the triangle. In the obtuse angled triangle, the circumcenter is located in the exterior of the triangle. Now let's think over it. There were 3 brokers. They lived in a same village. They have decided to construct a temple in such a way that the temple should be at the same distance from their homes. How to find the position of such a temple? Answer. Let the 3 houses of brokers be house A, house B, and house C. Now join the 3 points. We get a triangle ABC. Now cut the perpendicular bisectors on side AB and BC. The point where these bisectors meet is point O, that is the center. Now join OA, OB, and OC. Thus, from point O, draw a circle with the radius OA passing through point A, B, and C, that is the circumcircle. Thus, we can conclude that the position of the temple is at the center from the houses of brokers. Now let's solve another activity. Draw the following types of triangles and complete the given table. Answer. In the scalene triangle, the circumcenter is located inside the triangle. In the isosceles triangle, the circumcenter is inside the triangle. In the equilateral triangle, the circumcenter is inside the triangle. Now let's see how to construct incircle of a triangle. Before we begin the construction, let's try to understand the relation between circle and triangle. Look at the figure. Here, the circle is touching each side of the triangle. Points A, B, and C are points of contact. We know that a tangent to a circle is a perpendicular to the radius at the point of contact. Now, let point I be the incenter of the circle. Therefore, IA is perpendicular to side PQ. IB is perpendicular to side QR. IC is perpendicular to side PR. Therefore, IA, IB, and IC are the radii of the same circle. Segment IA is congruent to segment IB is congruent to segment IC. Therefore, point I is the equidistant from the sides PQ, QR, and PR. We know that if the point in the plane of an angle is equidistant from the sides of the angle, then it lies on the angle bisector. We also know that angle bisectors of a triangle are concurrent. Therefore, point I is the point of concurrence of the angle bisectors of angle PQR, angle QPR, and angle PRQ. A circle with center I and radius IA is the incircle of the triangle PQR. Thus, the circle which touches all the three sides of a triangle is called the incircle of a triangle. Let's look at an example. Draw the incircle of triangle XYZ such that XY is equal to 6.1 centimeters, YZ is equal to 5.7 centimeters, and measure of angle XYZ is equal to 65 degrees. Solution. First, draw segment XY of length 6.1 centimeters. Measure 65 degrees from point Y and mark a point. Now, draw an arc from point Y of length 5.7 centimeter and mark that point as Z. Also draw segment XZ. You get the required triangle XYZ. Now draw the angle bisectors of angle X and angle Y. Let these bisectors intersect at point I. Now draw a perpendicular from point I on the side XY. Point M is said to be the foot of perpendicular. Now draw a circle with the radius MI and center at I. Let's solve an activity related to incircle. Look at the screen. We have drawn different types of triangles with their incircles. Let's write the inference about the location of the incenter in the given table. In the scalene triangle, the incenter is located in the interior. In the isosceles triangle, the incenter is located in the interior. In the equilateral triangle, the incenter is located in the interior. In the right angle triangle, the incenter is located in the interior of triangle. In the acute angled triangle, the incenter is located in the interior of triangle. In the obtuse angled triangle, the incenter is located in the interior of triangle. Let's think it over. In the figure, let AB, BC, and AC are the three roads. Now let's see how to find the position of the tower which is equidistant from the three roads. Answer. Here, in the figure, it is given that AB, BC, and AC are the three roads which are equidistant from the three roads. Here, when all the three roads AB, BC, and AC are joined, we get triangle ABC. Now draw the angle bisectors of angle B and angle C. Let these bisectors intersect at point I. Now draw a perpendicular from point I on the side BC. Point M is said to be the foot of perpendicular. Now draw a circle with the radius MI and center at I. Thus, we can get an incircle. Thus, we can conclude that tower is in the center of the incircle, that is at point I of the triangle ABC. Now let's solve exercise 3.1. Question 1. Draw the circumcircle of triangle PMT such that PM is equal to 5.4 centimeters, angle P is equal to 60 degrees, angle M is equal to 70 degrees. Solution. Let's look at the construction. First, draw segment PM of length 5.4 centimeters. Measure 60 degrees from point P and draw a ray. Now, measure 70 degrees from point M and draw a ray. Now mark the point of intersection as T. Thus, we get the required triangle PMT. Taking more than half the distance, first keep point of compass on point P, then on M, and draw intersecting arcs above and below segment PM. Draw a line L passing through points of intersection of these arcs. This is the perpendicular bisector of side PM. Let the point of intersection of side PM be A. Similarly, draw perpendicular bisector of side MT, that is line N. Let the point of intersection of side MT be B. Mark the point of intersection of the lines L and N as O. Now, take OP as radius and O as center. Draw a circle touching the vertices of the triangle PMT. Thus, this is the circumcircle of the triangle PMT. Question 2. Construct the circumcircle of triangle SIM such that SI is equal to 6.5 centimeters, angle I is equal to 125 degrees, IM is equal to 4.4 centimeters. First, draw segment SI of length 6.5 centimeters. Measure 125 degrees from point I and mark a point. Draw an arc from point I of length 4.4 centimeters and mark that point as M. Join IM. Also draw segment MS. Thus, we get the required triangle SIM. Now, keep point of compass first on point S, then on I, and draw intersecting arcs above and below segment SI. Draw a line L passing through points of intersection of these arcs. This is the perpendicular bisector of side SI. Similarly, draw a perpendicular bisector of side SM, that is line N. Mark the point of intersection of the lines L and N as O. As triangle SIM is an obtuse angled triangle, the circumcenter O is outside the triangle. Let the point of intersection of side SI be R. Now take OS as radius and O as center. Draw a circle touching the vertices of the triangle SIM. This is the circumcircle of the triangle SIM. Question 3. Construct the incircle of triangle RST such that RS is equal to 6 centimeters, ST is equal to 7 centimeters, and RT is equal to 6.5 centimeters. Solution. First, draw segment ST of length 7 centimeters. Now, draw an arc from point T of length 6.5 centimeters. Now, again draw an arc from point S of length 6 centimeters and mark that point as R. Join RS. Also draw segment RT. You get the required triangle R, S, T. Now draw the angle bisectors of angle S and angle T. Let these bisectors intersect at point I. Now draw a perpendicular from point I on the side ST. Point M is said to be the foot of perpendicular. Now draw a circle with the radius MI and center at I. Question 4. Construct the incircle of triangle DEF in which DE is equal to EF is equal to 5.8 centimeters and angle DEF is equal to 65 degrees. Solution. First, draw segment DE of length 5.8 centimeters. Measure 65 degrees from point E and mark a point. Now, draw an arc from point E of length 5.8 centimeters and mark that point as F. Join DF. You get the required triangle DEF. Now, draw the angle bisectors of angle E and angle F. Let these bisectors intersect at point I. Now draw a perpendicular from point I on the side EF. Point M is said to be the foot of perpendicular. Now draw a circle with the radius MI and center at I. Question 5. Construct the circumcircle and incircle of an equilateral triangle, triangle X, Y, Z with side 6.3 centimeters. Solution. First, draw segment YZ of length 6.3 centimeters. Now, draw an arc from point Y of length 6.3 centimeters. Now, again draw an arc from point Z of length 6.3 centimeters and mark that point as X. Join XY. Also draw segment XZ. You get the required triangle XYZ. Now draw angle bisectors of angle Y and angle Z. Let P be the point of intersection of the angle bisectors. Draw PM perpendicular to side YZ. Now draw a circle with radius PM. Thus, the circle obtained is the required incircle of triangle XYZ. In an equilateral triangle, the center of incircle and the center of the circumcircle are same. Therefore, draw a circle with radius PX. Thus, the circle now obtained is the circumcircle of triangle XYZ.